All right, good morning, everyone, and welcome to Agriculture 104, Grassy Weeds in the Prairies, the Pests, the Problems, the Plans, with special guest Dr. Breanne Tidemann. My name is Rachel Evans. I'm the Technical Sales Manager for the Eastern Prairies region at FMC Canada, and I'll be kicking things off today. We will have time for questions at the end of the webinar, and we'll be looking for some feedback through a couple of poll questions, and that'll be facilitated by my counterpart, Nolan Kowalchuk, Technical Sales Manager for the Western Prairies region. Now, before we get started, you might be wondering, what is preschool? FMC Preschool is an education and stewardship extension of FMC Canada. We have a firm mandate to educate and bring value to customers and stakeholders regarding proactive weed control and resistance management best practices. Preschool is product agnostic, which means that we're here to talk about all the available solutions in order to present the best possible outcomes to our farm customers. If you'd like to learn more or you've missed one of our past webinars shown here, please check out our website at fmcpreschool.com. FMC Preschool is developed by our faculty members, a multifaceted team that includes marketing, sales, agronomy, and communications. And this team works really hard to make sure that we're bringing the most relevant and holistic content to you. Now, back to why we're here today. I am so pleased to introduce our guest speaker, Dr. Breanne Tidemann. Breanne is a research scientist with AAFC in Lacombe, Alberta. She completed all of her education at the U of A. Her research program focuses on management of resistant weeds, integrated weed management strategies, weed biology, and alternative weed control. Topics that she's going to cover off here for us today. She lives in Blackfelds, Alberta with her husband and her 2 sons. So welcome, Breanne, and take it away.
All right, thank you, Rachel. Good morning, everyone, and thank you for tuning in. I am going to be focusing on grassy weeds in the prairies, so apologies to any of those that are not from the prairies or in different regions of Canada, but hopefully there's still something interesting or informative that you can take away from this today. Before we get into things, I need to take a moment to thank my technical crew and the summer and the co-op students that work with me. Without them, I would really have no data or information to present to you. So I always like to send a shout out to them, as well as all of the funders of my research program in Lacombe. So a little bit about where we're going today. In terms of grassy weeds in the prairies, we're going to focus on wild oat, foxtail species, both green and yellow, as well as the brome species, both downy and Japanese brome. I want to talk to you a little bit about their biology, sort of how they grow and where they grow, as well as resistance issues, and then we'll talk about some integrated weed management strategies. And for that, I am going to focus on wild oat. It's where a lot of my research has been and my predecessors' research has been, and so that's kind of where we're going to focus, although a lot of those strategies should still be relevant to those other species as well. So let's talk about wild oat. Wild oat is an annual weed that is prone to flushing, which is probably a point of annoyance for many of you in the audience. It has no auricles and it has a high membranous ligule, and I will show you a little bit about what that looks like to help with identification in just a second. The typical seed bank duration is 4 to 5 years, but viable seeds have been found after 9 years. Now, I get a lot of aggravated tweets, emails, conversations about that seed bank duration being only 4 to 5 years, that we know wild oats last a whole lot longer than that. And you're not wrong, but when we talk about the seed bank duration, we're talking about a decay curve like this over here. And so when we say 4 to 5 years, we're talking the vast majority of those seeds are probably gone in 4 to 5 years. However, this little tail end is where you're going to get those lingerers that are there for, 9, 10, 15 years. So there is always that small percentage that can last longer, but the majority of those seeds will expire in the seed bank between 4 to 5 years. Wild oats are highly competitive, particularly if they emerge before the crop, and they are found in all Canadian provinces and all but 4 of the US states. It's primarily a selfing plant, which makes it a little bit different than some of the other problem weeds in other areas of the world, like, say, ryegrass in Australia. So this is my identification slide. This is an infographic that was put together by the Resistant Wild Oat Action Committee, and their website is on the screen there. And this is one of the ways that I was taught to identify wild oat, and it's to thank Elvis. So if we talk about the ligule, that high membranous ligule here that you can see against the stem, that's like Elvis's popped collar. We've got a deep V in the collar region of the sheath, which, you know, Elvis was kind of famous for. We've got some tassels on the leaf margins here, which are these small hairs, and you might even get the counterclockwise hip swivel or that counterclockwise twist in the leaf. Now, you hear that counterclockwise twist a lot when people are talking about wild oat ID. It's actually not as consistent as these other three ways of identifying it. It's relatively consistent, but not always consistent in the field. So don't rely on just that counterclockwise twist when you're IDing wild oats. Let's talk about the foxtail species here now in terms of their biology. Both of these are annual weeds. Neither of them have auricles, and their ligules are both a fringe of hair. So based on those typical sort of ID characteristics that we often use for grasses, it's a little bit of a challenge. But green foxtail has hairs only on the leaf margin, where yellow foxtail has long hairs on the upper surface of the leaves. And I'll show you again pictures of these in just a second. Green foxtail is found in all provinces of Canada. Yellow foxtail used to be isolated to the southern parts of some of the provinces, British Columbia, and east of the Great Lakes. Now, there's been a shift in this, and we're going to talk about this when we look at sort of where things are growing here in just a sec. But yellow foxtail, just so that sort of some foreshadowing here, it's a bit on the move. Green foxtail seeds can germinate for up to 30 years in the soil, and the deeper they're buried, the longer they tend to be viable. Now, again, this is that tail end number, that 30 years. We're looking less than that for the majority of the seed bank. Compare this to yellow foxtail, where 3% of the seeds are viable for up to 13 years and 0% were viable after 15 years. So yellow foxtail is not as persistent in the seed bank as green foxtail is. So let's look at these visually here. Here you can see that fringe of hair in the green foxtail, but you'll notice that there's no hairs on this upper surface of the leaf. If you compare that to the yellow foxtail on this side, you can see those long white hairs on the upper surface of the leaf. That is one of the key differences between these two species. I'm going to show you some more pictures here. This is a slide from Manitoba Agriculture. Again, you can see that fringe here for the green foxtail, the fringe here for the yellow foxtail as well. But that upper surface of the leaf and the presence or absence of those long hairs is what really tells them apart. Now, if these weeds have reached maturity, their seeds are much, much different in size as well. So here's a green foxtail seed head. Here's a yellow foxtail seed head. The yellow foxtail seeds are 2 to 3 times the size of the green foxtail seeds. And they really do stand out. If you're looking at just the seeds side by side, you can pick out very easily which one is which. One more seed head comparison, because you can really see the size difference of those seeds. Again, green foxtail on the left, yellow foxtail on the right. And just look at, ignoring the awns, the actual size of the seed that's attached to that head and how much bigger the yellow foxtail ones are. So at maturity, they are relatively easy to tell apart from one another. At the seedling stage, you're really looking for those long hairs on the leaf surface. The brome species. So Japanese brome is a winter annual, where downy brome is an annual, winter annual, or biennial. So there is overlap there. Now you'll notice the wording here for the ligule is the same for both of them. It is a membranous shredded ligule, which means it's a jaggedy edge at the top. Now the Japanese brome has more of a blunt point, and the downy brome has more of sharp points within those ligules. And again, I'll show you pictures, but they can be very tough to tell apart. These bromes, again, are found in most Canadian provinces. There are herbarium specimens collected from across the provinces. They tend to stay more central southern. Japanese brome, I couldn't find any burial studies with looking at the seed bank viability. It is expected to be a short viable seed in the seed bank because it has low levels of dormancy. Downy brome, we're looking at 2 to 5 year seed bank. So still a relatively short-ish seed bank compared to some of the other species. At maturity, Japanese brome has a curled on, where downy brome has a straight on. That's one of the few differentiating characteristics, unfortunately, between these species. And I can tell you with confidence that even as weed scientists or weed specialists, we have trouble telling these two apart. They're pretty tricky. So not fabulous images here, but we've got Japanese brome on the left, downy brome on the right. And you can see this ligule here has relatively blunt ends where it's shredded compared to these super pointy, sharp ends on the downy brome. Again, it's a fairly subtle difference, but there is a bit of a difference there. Another comparison here, and both of these brome pictures came from Clark Brenzel here as well. I forgot to put that in. So this is Japanese brome on the left, downy brome on the right. These were grown in a growth cabinet. And one of the differences that they noticed was that the Japanese brome has this sort of purple coloration at the crown of the plant, but not throughout the leaves, where the downy brome has that coloration throughout the leaves and not so much at the crown. So again, it's very subtle differences between these two species, but there are some that can help try and sort of pull these apart in terms of identification. So let's talk about where these weeds are located within the provinces and how abundant they are. And I want to thank Julia Leeson. All of the data and the maps that I'm going to show you are coming from her weed surveys. So starting with wild oat, this is Alberta, Saskatchewan. We'll move to Manitoba next. What you can see, these are historical maps from the 70s, 80s, 90s, early 2000s, 2010, and then 2017. The darker blue color means that there are more wild oats there. They're more frequent. And so what you can see is over time, the populations of wild oat have actually decreased, but they are still present across the province. And there's still sort of hot pockets of where they are most prevalent throughout the province. Saskatchewan is showing a higher frequency of wild oats, particularly sort of this central northern part as we move towards the east. It has reduced as well since the 1970s, but it is quite common. If we look at these tables just briefly, I just want to focus on the rank. You can see typically wild oat in Alberta is in the top 3 in terms of our most abundant weeds. It dropped to number 5 in 2017. And in Saskatchewan, it's typically number 3. It jumped up to number 2 here in the last survey. So it's, you know, within the top 5, it is one of our most problematic weeds in these two provinces. We go to Manitoba, again, you see a reduction in wild oat frequency over time, a couple of hot pockets here still, and it also dropped in 2016 to number 4 overall, but again, still in the top 5, still one of those top problem weeds. If we look at the foxtail species in Alberta and Saskatchewan here, we are only looking at green foxtail. Again, you see a decrease in frequency over time, and you can see it has always essentially been focused in this sort of east central Alberta region. It's jumped around a bit in terms of the rankings, sort of was number 4, kind of went to the mid-teens, then made it back to the top 10, so it kind of fluctuates a little bit in Alberta in terms of its prevalence. In Saskatchewan, it's still really quite dominant. It has not shown that same frequency decrease across the province as it has in Alberta, and it is continually ranked number 1 in these surveys. It is the most abundant weed that they are finding across Saskatchewan. Now, just for interest's sake, yellow foxtail was found for the first time in Saskatchewan, or documented for the first time in Saskatchewan in the 2014-15 survey. So that is a fairly new weed, at least to these weed surveys in terms of documentation. In Manitoba, there are maps for both green and yellow foxtail. So again, green foxtail, we do see a decrease in frequency, but again, some very solid hot pockets through Manitoba here. And again, it is the most abundant weed to be found in Manitoba. Yellow foxtail, you can see it was very sporadic all the way through here. And then as we've moved into the 2000s, it starts to be a lot more common. So if we look at the actual rankings, it started at number 48 and we have moved up to number 6th overall. So it went from just being in the top 50 to now being in the top 10. So we are seeing a serious increase in terms of its relative abundance to other weed species in Manitoba. It's becoming more and more of a problem, and we're going to talk a little bit about why that might be here in a little bit. Now the brome species, they're not breaking the top 25, so there's no maps for those. They are mostly found in the southern parts of the provinces. There hasn't been a super noticeable shift. They're not really showing up in sort of those species with the most changes or anything like that. So we know they're there, but they're not a huge influx yet, not like we're seeing with the yellow foxtail with sort of a steadily increasing presence, at least at this point. Now, the newest survey in Saskatchewan was done in 2019 and 2021, so these are just sort of brand new results. And I just wanted to show you guys here, again, green foxtail is the number 1 weed in terms of relative abundance. Wild oat is number 3. The bromes, again, are not listed on here. They're not breaking that top 25. But sort of par for the course with green foxtail and wild oat, they are still in that top 5 problematic weeds in Saskatchewan. Moving into herbicide resistance now. So some of why these weeds are such a problem or such a concern. And I need to thank Hugh, Becky, Charles Geddes, and our other colleagues for the maps and the data that I'm going to show you here. So these maps are from the 2014 to 2017 resistance survey, and I'll explain why in a little bit here, but I wanted to start with wild oat. Looking at group 1 resistance in terms of the fields that had wild oat where it was tested, 62% of those were group 1 resistant populations in this 2014 to 2017 survey. Group 2 resistance is not as prevalent. It's about a third of the populations that were tested, again, across the prairies. But if you look at these maps, the white dots are resistant populations, the black dots are susceptible populations. And what you can see is that group 1 and group 2 resistance is essentially spread across the entire prairies. It's not a specific province's problem, it's a prairie-wide problem with group 1 and 2 resistant wild oat. Group 1 plus 2 resistance, so resistant to both groups, is about 27% of the populations that were tested, again, spread across the prairies. Now, we do have other known resistance with wild oat. We do have trialate or Avodex resistance. Trialate was formerly a group 8 herbicide. It has now been reclassified to a group 15. We also have confirmed resistance to group 14 and 15 products, with this group 15 being pyroxasulfone. So previously we said we had 1, 2, 8, 14, and 15. With trialate being reclassified to a 15, it's now 1, 2, 14, 15. Now, does that mean that any trialate resistant wild oats are automatically resistant to the other group 15s like pyroxasulfone? We don't know that yet. We don't know some of those cross resistance issues there, whether it'll be like the group 1s where you can have separate FOP and DIM and DAN resistance. Maybe you can have trialate and pyroxasulfone resistance that are separate, or if they're overlapping. We don't know that yet. That reclassification is just new. In Australia, there is also confirmed glyphosate resistant in wild oat, which is of significant concern for us because that's been one of our at-risk species for glyphosate resistance here in the prairies. Now, these survey maps were from 14 to 17, 2014 to 2017. Manitoba, the samples for the resistance survey were collected in 2022, which means they are just starting to be screened right now in Charles's lab in Lethbridge. Alberta will be collected in 2023, but we do have updated results from Saskatchewan. So I did want to share those with you just to sort of see where some of those trends are going with some of these resistances. So if we look at wild oat resistance to group 1s in Saskatchewan, 77% of tested fields were coming back as positive for group 1 resistance, which is 47% of all fields surveyed. So if you have a wild oat still in the field at the time of harvest and that there was enough seed there for us to do a test, 77% of those were resistant to group 1s. And you can see here on this graph, this is the increase in the percent of fields with resistant wild oat over the various surveys that have been done. And so the square boxes are Saskatchewan, and you can see that increase here in the most recent survey now. So it is a relatively linear increase in frequency of group 1 resistance in these surveys. We look at group 2 resistance, we've actually had a little bit of a plateau here. We're looking at about a third of fields that have group 2 resistance in Saskatchewan based on this last survey. So it's definitely still an issue. We are seeing a bit of a plateau. Whether or not that will continue in future surveys will be very interesting to see. You can see here we had a little bit of a plateau right at the start and then a fairly sharp increase. So it will be very interesting to sort of monitor how that resistance progresses in the future. And then group 1 and 2 resistance, again, we're seeing a bit of a plateau. So about a quarter of the populations tested had multiple resistance to group 1s and 2s. Switching species to green foxtail, back to the 2014 to 2017 surveys, group 1 resistant group foxtail was about a quarter of the populations. Group 2 resistant green foxtail was 11% of tested populations. And again, those resistances are fairly scattered throughout the prairies. Group 1 and 2 resistant green foxtail, there was 1 field in Manitoba and 2 fields in Saskatchewan in that previous survey that had multiple resistance. Yellow foxtail, really only an issue in Manitoba in the 14 to 17 survey, and I pulled this out of Hugh Becky's actual paper just to share this with you. So group 1 resistant yellow foxtail was found in 19 fields where the weed was sampled, so about a third of the fields where it was sampled. Group 2 resistant yellow foxtail was found in 10 fields, or 17% of the sample populations. 4 fields had group 1 and 2 resistant yellow foxtail. So remembering again that this is a relatively new weed in terms of its dominance or abundance in the area, and we're already dealing with a third of those populations having group 1 resistance. That's a really rapid increase in resistance compared to something like our wild oats, which has been a little bit slower over time. And so this is a bit of a concern. I'm going to come back to this in a slide or two here. Again, going back to Charles's update here from the Saskatchewan survey, 28% of tested fields had a group 1 resistant green foxtail. Again, you can see the increase over here in this line. Yellow foxtail. There was 3 fields that had yellow foxtail in southeastern Saskatchewan here. So again, this is a new species that was tested in the Saskatchewan survey. It wasn't there in previous surveys. All 3 of those fields were resistant to group 1s with the yellow foxtail. So it's the first time we've actually collected it to survey for it, and all of those samples were group 1 resistant. So that is a bit of a concern. Obviously, it's not a lot of fields yet, but what seems to be coming in seems to be those resistant biotypes. And that is potentially part of the reason that we're seeing quite rapid establishment of this weed in Manitoba and now sort of moving into Saskatchewan, is that what is moving seems to be some of those resistant biotypes. Now the Brome species, primarily worldwide, we are seeing group 2 or group 5 resistance, but I wanted to highlight this one in particular here. This is from Alberta, where Charles confirmed group 9 or glyphosate resistant downy brome in Alberta. Prior to that, really, we haven't had resistant brome in Canada that's been confirmed. There is some group 2 resistance very close to us in the US, in Montana, and there are no globally reported incidents of, oops, sorry, I lied, one incidence of Japanese brome with group 2 resistance in the US as well. So there's not a lot of resistance in the brome species, but this glyphosate resistant downy brome is definitely a concern for us in Western Canada. And this is just a picture that I, again, stole from Charles, but this is the actual testing of the glyphosate-resistant brome species. You can see the resistant population here in the back, surviving 3,600 grams of acid equivalent per hectare. That is, 3 or 4 times the field rate of glyphosate. And it is still, as you can see, quite green and quite happy back here. So let's talk a little bit about management now. So we know these weeds are a problem. We know we've got resistance as a problem. So how the heck do we manage these things then? And as I mentioned, for the management part, we are going to have a focus on wild oat. It's where a lot of the research has been done, but some of this still should be applicable to other species as well. And I want to start by talking about integrated herbicide management. So when we're talking about utilizing tank mixes, utilizing multiple modes of action, pre's and posts and layering and all of that terminology, we're talking about a diversified herbicide management strategy. Now, if you are using tank mixes or 2 modes of action, tank mixes only help mitigate resistance and lower selection if they are 2 effective modes of action. And that is something that I think gets missed sometimes when we're talking about tank mixing. It's like, I've got 2 or 3 products in the tank, I'm good, but what are those products actually working on? Are at least 2 of them working on the same target weed? So utilizing 2 modes of action can be easy to say. It can be hard to do for a number of reasons, either having available tank mixes or dealing with resistance or any of those types of things. Now, this IHM terminology that I'm using, this was coined by Neil Harker and John O'Donovan. You're going to hear me use it throughout the rest of the presentation. So I want to talk a little bit about this potentially being hard to do. So this is a slide that Charles put together. I've got a couple older versions of it. I just want to talk about this concept for a second. In the Guide to Crop Protection from Alberta, our Blue Book, in 2019, this is the list of wild oat herbicide options in these various crops. Now, we don't have herbicide groups up here, but if we assume group 1 and 2 resistance, it starts to look like this. And if I summarize that a little nicer for you, if we assume group 1 and 2 resistance, these are the options that are left. One of the things that you'll notice is in many of these crops, all that is left here are pre-products. There are no post-in-crop herbicide options in these crops. You'll also notice I've left the old numbers here, so the group 8 Avidex, right? We've had trialate resistance in the past. Now, one of the things that I get asked is how common is it to actually have resistance to all of the group 1 subgroups and all of the group 2 subgroups? And I wanted to show you a little bit of data from a field that was data submitted to me by Dale Fedoruk in 2014. So this is the cropping history of this particular field called Field 3. So you can see use of cladinofop, phenoxaprop, clethodim, panoxidin, chalcoxidin, mazimethibins. All of those red highlighted products are group 1s or group 2s. That particular farmer had a resistance test done that fall, and these are his resistance test results. You can see high levels of resistance across the FOPs, the DIMs, the DENs, and across the group 2 subgroups. A little bit lower resistance to simplicity, but 66% resistant seeds is still quite high. So this is a realistic situation that producers are dealing with multiple resistance to the group 1s and 2s and having essentially no group 1s or 2 options left. This was in fall 2014. I'm hearing more and more of this from producers as time goes on that, you know, I did a resistance test and all my group 1s and 2s have resistance to them. So it's not an unusual situation. Now, if we also assume group 8 resistance, and in this case, I am just using trialate because again, we don't know what those cross resistances are, but we know trialate resistance was prevalent in central Alberta in the 90s. If you cross those out, again, it limits it even further. If there is cross resistance, which we don't know yet, to the group 15s, you lose more options yet. So your number of options shrinks very, very quickly as resistance becomes an issue in some of these grassy weeds. Now, I want to talk a little bit about the nuances of resistance. So when you have resistance in your field, things that you need to think about is where and how did you notice the resistance? Is it a small patch or is it your entire field that you had a chemical failure on? Did you resistance test? Where did you sample from? How broadly spread across your field is that resistance? And again, I want you to just think about the fact that confirmed resistance does not mean herbicide X is useless. Where and how much of that field was resistance? Can you patch manage? Those types of things. So if you had one small solid patch where you had really high levels of resistance to a group 1, but that group 1 is what you sprayed on your field and it controlled 90-some%. Tools manage what resistance you do have and where that resistance is in your field. Patch management is something that I think more of us need to be thinking about or talking about and trying to do when it is still a resistance patch. Now, if you're interested in resistance testing, again, I've got a Wild Oat Action Committee, Resistant Wild Oat Action Committee infographic up here on the screen. The link to their infographics is on the page. It lists sort of who does testing in the prairies, how much it'll cost you, and there's also some other infographics on that website for how to collect seeds for resistance testing and the procedures and things like that. Now I want to talk a little bit about herbicide layering. This is one tactic that you can use to get multiple effective modes of action within the same year on a target weed, but you do have to use a pre. Now pre's can be tougher to work with because you need moisture. If you've got high organic matter, it can be an issue. pH can affect how well it works or how long it carries over, and I get that. But one of the pushbacks that I hear more often than anything is that it doesn't give me as good a control as a post. So I'm looking at more of a suppression versus a control. But the thing that I want to highlight is that suppression is much, much better than nothing because resistance is a numbers game. So the more individuals that you are spraying with your post group 1 or group 2 in crop, or your glyphosate in crop or whatever in crop you're using, the more individuals you're spraying, the more likely you are to select for a resistance. If you can knock those numbers down with a pre first, you're selecting fewer individuals, you've got a chance at extending the lifetime of that post herbicide. So resistance is a numbers game. I do want to talk about, though, the longevity of only focusing on integrated herbicide management. Integrated herbicide management all uses herbicides. If you're using a herbicide, you're putting on a selection pressure for herbicide resistance. Even if you're tank mixing, even if you're using multiple effective modes of action, even if you're layering, if you're applying a herbicide, you are applying a selection pressure to that population for herbicide resistance. So if you want a longer term, more sustainable goal, you do have to actually move into integrated weed management. And I know some people hate even hearing that terminology, but it's the reality of what we're dealing with. Now, I also understand that some of these bubbles, for lack of another word, are harder to utilize in the field than others. Biological control is not the easiest thing to implement in our fields. We don't have a lot of options available to us in Canadian agriculture for biological applications on a commercial grain farm. But trying to utilize as many of these as possible can have a huge impact. So we're going to talk about IWM strategies now. And I guess the one thing that I want to talk about first is that we have gotten used to essentially an easy button weed control. Using herbicides for weed management is a form of easy button weed control because it's practical, it's economical for the most part, it's efficient, it's effective, and we're comfortable with it. We know how to spray herbicides. We know how to apply them. We know they're, for the most part, going to work unless we're dealing with resistance. It's been, you put it in the tank, you spray it, the weeds die. It's a fairly easy button, non-complex, non-complicated method of weed control. The chances of us finding something that will step into that role and cover off all 5 of these criteria is slim to none. We are moving away from that easy button weed control. It's going to get more complicated. It's going to take more time, more effort, more thought. And that is just sort of the reality of what we're dealing with at this point in time. Sorry for being a Debbie Downer this early in the morning. Okay, so digging into some of those IWM strategies. I want to talk about silaging. Early cut silaging, particularly of something like barley, can be really effective at driving down weed populations. Now, it's not selective to the weeds, but it can be very effective at controlling them. If you can adapt the timing of your silage, if you can do an early cut silage, say 1 to 2 weeks after head emergence, it can be really, really effective. You obviously have to have a market for it, but I want to talk about this for people that do have a market for it. Because silaging is really cutting the wild oats at panicle formation. They're just starting to form their seeds. That silage is taken off the field, so the seeds go with it. And hopefully in that process, you're getting those wild oats out of your field. This is research that Neil Harker did in the 90s, actually, where he had barley that was grown for grain without herbicides. And this is a wild oat density graph. So you can see the wild oat density increased when he grew barley for grain without any herbicides. If he grew barley for grain with full rates of herbicides, this is this green and yellow bars, our wild oat density stayed essentially fairly even from start to finish of this study. If he grew barley as an early cut silage with no herbicides, those were actually the lowest densities that he had at the end of this study by a substantial amount. So early cut silage, and I'm going to show this to you again in an integrated study that Neil did. I've seen the same results in an integrated study that I did. Early cut barley silage, if you double the seeding rate, you early silage it, can be incredibly effective at keeping those wild oat populations low. So moving into that integrated study of Neil's, Neil was comparing a continuous barley versus a barley canola barley pea rotation. So a straight barley versus a diverse rotation. He had a short barley cultivar versus a tall barley cultivar with the idea that the tall cultivar would be more competitive. In a 1x and a 2x seeding rate, 200 or 400 seeds per square meter. And then he did have herbicide rate in there. This study was conducted at a time when there was a lot more interest in cutting herbicide rates. We do not recommend cutting herbicide rates. We're going to ignore that factor altogether here for our purposes today. The treatments were applied to the same plots year after year after year, so we're looking at cumulative treatment effects. And what I want to show you is just this. This is looking at the reduction in wild oat biomass. So when he went from a 1x to a 2x seeding rate, he reduced wild oat biomass by about 3x. When he went from a short barley cultivar to a tall barley cultivar, he reduced wild oat biomass by about 2x. When he went from continuous barley to a more diverse rotation, 2.7x reduction. So a 2 to 3x reduction in biomass from doing one of those things. If you combine two of those things, say increasing the seeding rate and using a more competitive cultivar or diversifying the rotation, you had a 6 to 8x reduction in wild oat biomass. And if you did all three things, it was about a 19x reduction in wild oat biomass. So those strategies are additive or synergistic in terms of managing some of these grassy weeds. It increases the competitiveness, it reduces the weed's ability to compete in those crops. Neil then went on to another study with more diversity. He wanted to look at cultural wild oat management tactics with truly diverse rotations, not just a barley, canola, barley, pea, because that's just summer annuals. It's not all that diverse. He had 14 treatments in this study. I'm just going to highlight some of them really quickly, but I do want to highlight that all plots received a full rate of dicot herbicide. So what we're looking at is just the impact on the wild oats. That's all we were focused on in this particular study. So this is looking at wild oat densities, wild oat emergence across all 8 sites in 2014, which was the end of the study. And this bar at the bottom here, this is a canola wheat rotation with full herbicides, including wild oat herbicides in every year. What I want to highlight is these treatments up here that have the yellow boxes around them now. Each of these treatments had 3 years where herbicides were not applied. So this is a 3-year alfalfa rotation. This is early cut barley silage, winter triticale, early cut barley silage, same treatment but with winter wheat instead. Early cut barley silage and spring wheat, early cut barley silage and winter wheat. All of these at a 2x seeding rate. So increased seeding rate, diversified rotation, inclusion of silage or a perennial. And what I'm highlighting here is that all of these bars are green. And what that means is that statistically, those wild oat densities were the same as this canola wheat rotation with 100% herbicides. So if you look even numerically, we had 18 wild oats per square meter in the alfalfa rotation, 32 wild oats per square meter in the canola wheat rotation. So some of those 0 herbicide for 3 years, 0 for 3 years, were able to maintain densities statistically similar to a full canola wheat, full herbicide rotation. I want to talk quickly here about combining pre's and seeding rate. So we talked about pre-herbicides, we've talked about seeding rate. What if we put those two together? And this is a slide from Eric Johnson from the University of Saskatchewan. So this is in Saskatoon in 2021 and 22. With no pre-herbicide attached, increasing your seeding rate of wheat from 150 seeds per square meter to 300 to 450 resulted in wild oat biomass reductions of 46% by going from 150 to 300 seeds per square meter and 63% going to the 450. So a substantial decrease in wild oat biomass just from increasing your seeding rate. If you add the pre-herbicide into that, the pre-herbicide alone brought those wild oat biomasses down quite a bit, but seeding rate still had a proportional decrease in wild oat biomass by about 71% at the highest seeding rate compared to the lowest seeding rate. If you combine both of those things, we're looking at about an 80% reduction in wild oat biomass just from including the pre-herbicide. So we had a fairly effective pre here, but up to 94% by utilizing a pre and increasing those seeding rates. So those two things together can be a huge impact on driving down that grassy weed biomass, in this case, again, wild oat. But there's no reason to think that these tactics wouldn't work for something like green foxtail as well. Some visuals of this. This is the wheat that was seeded at 150 seeds per square meter. We have no pre-herbicide on the left, a pre-herbicide on the right. Ignore the IRWM, that's a different component of this study that I'm not talking about today. But you can see the impact of the pre at these low seeding rates on managing those wild oat densities. As the seeding rate increases, you see a reduction in wild oat already just from increasing that seeding rate, and quite clean really when you include the pre compared to the highest seeding rate. And so what we're seeing is that increased competitiveness of the wheat helps drive those wild oats down in addition to that pre-herbicide. They're working together to manage those wild oats. A couple other management strategies, harvest weed seed control. I'm not going to go into detail on this. You've probably heard me talk about it in the past. Physical impact mills being one of the ones that we're most interested in, and there's 4 of them now on the market. The Redicop is our local Canadian one, and the integrated HSD, IHSD, and the Seed Terminator from Australia, as well as the Tech Farm Weed Hog. What I really want to show here is that, you know, we've seen that wild oat seed retention may not be a great option, therefore, for managing their densities with harvest weed seed control. However, one of the things that we're looking at is that harvest weed seed control might be really helpful for keeping resistant wild oat patches as patches. That's a study that we've got going on right now, looking at, you know, at least if we can not spread those resistant ones that are still on the plant across the field, maybe we can do a little bit more patch management. We've looked at clipping of wild oat panicles. Seed viability does increase quickly after panicle emergence. So once those wild oat panicles come out, within about 2 weeks, we're starting to see a fairly sharp climb in viability. Management of regrowth and tillering can be an issue with these strategies, but it can prevent seed bank inputs. And I just wanted to highlight that there are actually commercial versions. So this is what we do in the plots, is nippers and hedge trimmers. But in the commercial scale, this is the comb cut from Sweden. This is the weed clipper from Borgo. It's a 50-foot model. So there are actually tools to use to do this on a larger scale. Really, when we're talking about trying to manage weeds and grass species here in particular, we want to put more competition against them. So how do we get there? This is things like increasing your seeding rate, narrowing your row spacing, intercropping potentially. We haven't done the work on that yet, but that might help provide more competition against the weeds. Don't introduce the weeds in the first place. So using things like certified seed. Don't spread the weeds. Be conscious at harvest time. Make sure you're cleaning your equipment. And please, for the love of Pete, if you're bringing equipment from the US or somewhere like that, please clean that out so that we're not introducing things like Palmer amaranth. I've got enough issues with wild oat and cleavers and everything else. We don't want the Palmer pigweeds and any other issues from the US. So please clean that equipment. I've got kicking it old school here. So I've seen a lot more people talking things like stale seed beds, which is something that we used really before we had our post group 1s and 2s for wild oat. I've heard of guys pulling their rod weeders out of the bush and utilizing those again and having some pretty good success with it. But there are these other strategies that can be used as well. Competitive varieties, this is one that we talk about quite a bit, but how do we know which varieties are competitive? That's another ongoing project that we've got to try and help provide some of that information to producers. Other upcoming technologies, I have a question mark there. These are sort of futuristic ones that we don't know how well they're going to work. Things like electrical weeding in the top left corner there. Anecdotally, some of the other areas that electrical weeding has been studied, it has not been as effective on grass weeds because it doesn't conduct through to the tillers. So you'll get the main seed head, but you won't get any of the tillers. Laser weeding, something that sounds really cool. I'd love to play with one. I'm a little bit concerned about in no-till systems with the amount of residue that we can have sometimes that some of that might light on fire, but I still want to play with it. And then on the right-hand side, you've got some of those, the ag robots or the weeding robots that are on the market. These are mostly in horticulture or specialty crop production right now. But that technology is coming. The ability to identify the weeds and actually remove them with a robot is coming. How long till it gets into our broadacre crops? That's another question. But that technology is developing, that technology is coming, and we may see that incorporated into potential strategies in the future. Take-home messages. Grass weeds are problematic across the prairies. Herbicide resistance is increasing in those grasses. And really, resistance is a numbers game. So knock those numbers down wherever and whenever you can. It is important to use a good integrated herbicide management strategy, but it's also important to incorporate true integrated weed management strategies in addition. Get your canopy closed, give the crop as much competitive advantage as you can, and really think about trying to manage the weeds at all times in your cropping system, at emergence, while you're growing, at seed production, before you put the seed in the ground. What am I doing to manage these weeds here? That, I'd like to thank you a lot for tuning in this morning. I hope there was something useful in that presentation for you. Again, I do have the Wild Oat Action Committee website on the right-hand side if you want to go and take a look at some of those infographics, as well as my contact info if you want to get in touch. Thanks very much.
Excellent. Thanks, Breanne. That was absolutely fantastic. Just, you know, a number of the things that you covered off, from your overviews, your insight into resistance management, insight into wild oat resistance and just some of the gems out of that. Just absolutely, one key one here: increased crop competitiveness plus Prairies working together. So with that, I'm going to jump into the questions, and there was a number of them here, so hopefully we'll get through them. So the first one was how early, and this is in regards to when you're talking about green and yellow foxtail, and with yellow foxtail, how early can you begin to notice the hairs of the yellow foxtail?
So I want to say it's by about 2-leaf. I can tell you we've had some seed bank samples that we were growing out here from another research study. You can actually kind of see a difference between them even at that first leaf as they emerge between the yellow and the green. If they're both there, you can notice a difference between them. I can't verbalize really what the difference is, but looking at them, it was like, oh yeah, those two are different. That's a green and that's a yellow. But those hairs, usually it's fairly early on. You might have to get, nose to the plant to see them, or a hand lens might be helpful. But within, at that seedling stage, you are gonna start seeing those hairs. I would say 2 to 3 leaf, they should be there.
Excellent, thank you. The next question here is just in regards to, is there any info on the percentage of weeds that are resistant, or just if a resistant weed was there? And this is regards when you're talking about your wild oat resistance here.
Okay, so when you send samples into something like the Crop Protection Lab in Saskatchewan, what you get back is the percentage of your seeds that are resistant. When we're talking about the resistance surveys, if there is a resistant weed in that field, it gets marked as resistance. So there, in that sense, there's not sort of that scale of how frequent is it. Charles has some of that more for some of his kochia stuff, but I don't believe we have that for wild oats, and I may get an email from Charles in 5 minutes going, yes, we do, why'd you say that? But as far as I know, we don't have that scale of measurement on the resistance surveys for the grass data.
Excellent. The next one here, is there group 3 resistant wild oats or green foxtail?
I don't believe we have group 3 resistant wild oats confirmed. Honestly, I would have to look on the green foxtail. Something in my brain is wanting to tweak saying possibly, but I'm not positive off the top of my head. I don't believe we have it in Western Canada as far as I know. But I would like to double check on that one, and I will get back on that one.
Sure, perfect. And we can send that out also. So some of the questions that maybe we don't have a chance to get to here today.
Yeah.
The next question that came in was, just to make sure I got it here, with the 4 to 5 year seed bank on wild oats, would you be able to rotate back to a group 8 if you haven't used it in 15 to 20 years? I see you smiling on that one, Breanne.
Yeah, this is something. So John O'Donovan, who was at Lacombe when I started here, was one of the ones that first found trialate resistance, and so I spent a lot of time talking to him about it before he retired. There was a bit of a fitness penalty with trialate resistance, so we did expect to see sort of the dominance of that trait in the seed banks to reduce. Will it be gone? That's a very good question. And we know that selection doesn't take all that long because we had the resistance previously. So John's best guess was that you would have between 2 and 5 years of it being effective again if you previously had trialate resistance, and then you're going to start seeing that resistance become dominant in your population again. That was a best guess. I've seen a few folks in central Alberta that have switched back to trialate, and within 1 to 2 years are already saying, I've already got resistance showing back up again. I've got others that are like, oh, I've been using this for 5 years already and haven't had a problem. So it is variable in terms of what's left in your seed bank and how often you're using it and all of those kinds of things. So there's a chance that it might be effective again for a few years, but how long it'll be effective is still a bit of a question.
Yeah, you bet. No, a lot of variation there. The next one here is, Breanne, we're finding that often when we have multiple group 1 and group 2 resistance, we're finding that, references Clearfield herbicides, the Mazamox, are still testing within efficacy. is there a difference in mode of action with the specific group 2 that is causing this?
So wild oats and resistance are a pain in the butt, for lack of another way of explaining it. So we know we have the FOPs, DIMs, and DENs in the group 1s. We know we've got multiple subgroups in the group 2s. What they are resistant to in terms of, is it across all the group 1 subgroups? Is it across all the group 2 subgroups? Is it only DIMs and IMIs? Is it, DENs and SUs? How that all works out depends on the mechanism of resistance in that particular plant. So is it this specific amino acid substitution? Is it that specific amino acid substitution? Is it metabolism? And all of those can generate a different pattern of cross resistance. Do we know exactly what pattern is caused by selection with certain products? No. Do we know based on, if you tell me I sprayed this and this and I have resistance, can I spray that? I can't tell you that, because it's incredibly hard to predict without knowing the actual mechanism of resistance, and testing for the mechanism of resistance is incredibly difficult. It's easy to test for target site mutations. Metabolism is really hard to test for, and if it's metabolism based, again, that pattern of what it's resistant to can change. So the patterns of resistance with group 1 and 2 resistance in wild oats are really, really complicated and really unclear and messy, essentially. So there's no obvious evidence that selection with one specific type of herbicide will still allow you to use others or anything like that. It's not information that we've got on those patterns of resistance right now.
Right on, excellent. The next one here is just, at what point is a wild oat seed viable?
So within a week after panicle emergence, I had up to 10% wild oat viability. So what we did is, when the wild oat emerged, when the panicle emerged, we gave it a week, we clipped those off, we dried down the seeds, and then we tried germinating them about 4 to 6 months later, when any dormancy would have worn off. And we did have some low levels of viability within that first week after panicle emergence. Most of those seeds are going to be viable within 2 to 3 weeks, is sort of where you start seeing that 50 to 60% viability mark. So it is quite quickly after panicle emergence. If those seeds are dropping from the panicle, they're almost guaranteed to be viable.
Okay, cool. The next one, and there's a couple questions just in regards to cereal spacing and, your thoughts on 15-inch cereal spacing, and maybe you just want to kind of touch upon that. You did in the presentation, but just a little more for your insight.
Yeah, so what we've seen, and there is variability here. Typically, narrower row spacings are better for weed management, period. Are they better for every other aspect of your system? Not necessarily. You may see more issues with pathogens or things like that, but generally, from a weed competition perspective, narrower is better. So if you have a choice between a 12 or a 15, as a weed scientist, I'm going to say go 12, because that's more competition against those weeds. Is it the worst thing in the world to go from, say, a 12 to a 15? Not necessarily. Are you increasing your seeding rate to account for that? How high do I have to increase it to account for that? Well, I don't necessarily have a direct correlation there either. How high can you go in terms of your seeding rate to account for wider row spacing? There is a plateau. The row spacing is going to affect what that plateau is. But at some point, you're going to put so many seeds in a row that they're competing with each other as much or more than they're competing with your weeds, right? So there's a plateau for how high you can go with your seeding rate to mitigate going to a wider row spacing. Your best bet in terms of weed competition is a narrower row and a higher seeding rate.
Right on.
Yeah.
Okay, there's several more questions here, and we're not going to have time, but I'm going to just sneak one more in, and this is a good one as well. There's a lot here, but I'm just going to go through it here. So over the last few years, we've seen products with 2 active ingredients from the same groups, such as, say, phenoxaprop and pinoxidin, combinations of cladinifop and pidoxidin. I think you know where this is going, Breanne. And with these combinations, are they effective to help manage resistance, or do they potentially accelerate resistance? You know, if we know there's a percentage of resistance to phenoxaprop or cladinofop, should we even consider these products or these combinations? Might be a hard one to answer, but that's interesting.
Oh, you're putting me on the spot here. Okay. I'm trying to decide where to start with it. You're still spraying 2 group 1s. And I just talked about that, you know, the resistance patterns are messy. So if you're spraying 2 group 1s, you may get broader control over your field because, you know, what's resistant to one group, the other one's getting, and vice versa. So short term, it might be very successful in terms of managing some of your resistance issues. Long term, you're applying 2 group 1s. So you are increasing your selection pressure for group 1 resistance, particularly if you already have some pre-existing resistance to both groups. In my mind, at least, you're probably selecting for resistance to both of them. Having said that, there's work that's been done in Australia on ryegrass, and I want to emphasize it's in Australia on ryegrass, where they've taken products where they have resistance to 2 products, but when you mix them together, they're actually getting effective control. We don't have research on that in Canada yet. It's something I'm interested in. It's something I know Charles and Sean are both interested in, my colleagues at AAFC, but we can only do so much in a year. And so we really don't know. So, I mean, short term, do you have other options? Would be, I guess, one of my questions. What are your levels of resistance like right now in your field? And long term, if you have other options that are not just relying on multiple group 1s, I would probably lean more towards those just from that long-term selection pressure perspective. But again, there's a lot of questions there that we don't have answers to yet in terms of is that effective and what does that do to selection pressure and things like that. So I don't know that I have a solid answer to that for you, unfortunately, because we don't have the research on it yet. But I would be hesitant to suggest that as a primary method of managing resistance. I would suggest if you have other group options, that those might be a better tool. And I would suggest looking at some of the other easier to implement strategies like using an increased seeding rate maybe first.
I want to thank Breanne again for agreeing to be our guest speaker for our 4th webinar through FMC Preschool. I think obviously this is a tremendous topic, and you just did a great job, Breanne, of covering this in an easily accessible way, and I think gave lots of information for people to think about as we head into the 2023 growing season. So thank you again from FMC. We greatly appreciate it.
Thanks for having me. It was a lot of fun.
And so with that, I will wrap things up here, and thank you everyone for joining us this morning for FMC Preschool. We'll see you next time.